Hello, this is Chengyi. Today we will be discussing the applications of linear systems in science and engineering. We will discuss the basic applications of linear systems in chemistry and electricity. First, allow me to briefly introduce the concept of linear systems. A linear system is a system of linear equations, where the degree of all variables is 1. Linear equations can effectively represent the linear relationships between variables and describe the state of the system. As a result, they are widely applied in science and engineering. Now we can discuss the application of linear systems in chemistry. Linear systems can be applied in balancing chemical equations, which involves determining the coefficients for each material in a chemical equation so that the algebraic sum of atoms on both sides of the equation is equal. Let's first look at a very simple reaction. Hydrogen reacts with oxygen to form water. This reaction is so straightforward that we can easily determine the appropriate coefficients by observation. That is this equation. But what if the equation becomes more complex? Consider a more complex example. Ammonia reacts with oxygen to form nitrogen monoxide and water. This is a very classic reaction known as the Ostwald process, which is the foundation for industrial nitric and nitric acid production. To solve this question, we can first assume the coefficients of each materials as A, B, C, and D. Based on the previously mentioned rules, we can set up a system of equations. And we can rewrite the equations into another form, like this. Next, we will express this system as a matrix, which better describes the linear system. By performing elementary row operations to transform the matrix into its RREF, it is obvious that the matrix is consistent. Then we can find the solution to this system. It is clearly that D is a free variable. To ensure that each coefficient is an integer, we can set D equals to 6, which gives A equals to 4, B equals to 5, and C equals to 4. Finally, by substituting the coefficients back into the original equation, we have successfully balanced the equation. In fact, this is also a simple example. For more complex equations, such as those involving organic compounds or intricate materials, solving them with linear systems shows the significant advantages. My presentation is over. Thanks for listening.
This is Bingzhang, and here is my session. The application of linear systems in analyzing circuits. Linear systems are widely used in electrical engineering, and it is applied in analyzing circuits, particularly using the method such as the node voltage method or mesh current method, and it can lead to linear equations describing the relationships between current, voltage, and resistance in circuits. And it is especially valuable in analyzing a large, complex circuit systematically. And here is an example, and we can use the node current method to solve it. It's like this, and how can we find the voltage of N1 and N2 as V1 and V2? So first, let's analyze the whole circuit. For circuits, it has a constant current source S1, which is equals to 10 ampere, and it has 5 resistance, R1 to R5. And it has 3 nodes that we need to analyze. And especially for N3, it is earthed. That means the voltage of N3 equals to 0. We need to analyze the voltage of N1 and N2. So first we need to form equations according to Hirsch's current law. That is, the current come in to the node equals to the current come out from the node. For N1, it has S1's current come in and the current of R1, R3, R2 come out. For N2, it has the current of R2 come in and the current of R4, R5 come out. So we can form the equations. For N1, V1 minus 0, which is the voltage of N3 over R1 plus V1 minus 0 over R3 plus V1 and V2 over R2 equals to S1. And for N2, V2 minus 0 over R4 plus V2 over 0 minus 0 over R5 equals to V1 minus V2 over R2. And then we can simplify those equations and use it to make a linear system. And then we used raw operation to simplify this to an REF form. And we have the solution. V1 equals to 23 over 13, and V2 equals to 21 over 65, which is merely equals to 1.77 and 0.32. So the answer is the voltage of N1 equals to 1.77 volt. The voltage of N2 equals to 0.32 volt. So as we can see, linear system plays a crucial role in engineering and chemical balancing. So it can provide a systematic way to solve the problems involving multiple variables and constraints. So first, for chemical balancing, it can ensure the conservation, mass, and charge. It is especially useful for complex reactions involving multiple elements and compounds, and it can providing an efficient solution. And second, for circuits analysis, actually, the linear systems are widely used in electrical engineering, and it can help us analyze large, complex questions with precision and efficiency. And we can find those features of this method. Both applications benefit from the inherent properties of linear systems. So the first is scalability. That is, they can handle systems with many variables and constraints. Second, it is precision. All the solutions are mathematically exact. So the linear systems can provide a framework for solving problems in diverse fields, which demonstrates its fundamental importance in science and engineering. And that is our presentation.